Hello everyone, my name is Jinu Kim from Kent State University. I'm going to introduce the paper called Immersive Haptic Interface Simulating Skin Biopsy for Dermatological Skill Training. The presentation follows this flow. These days, many medical training systems in virtual reality with haptic is used because there are many benefits. It provides more realistic environments and they do not consume resources. There are many approaches such as laboratory surgery simulator, a haptic interface for endoscopic surgery by Tapacoli, NeuroTouch. The NeuroTouch is a physics-based virtual simulator for cranial microneurosurgery training by Dalom. Furthermore, this system is used in suturing, dental, and many other uh, medical fields. However, there is no system optimized for training in dermatology field. For these reasons, we developed the virtual reality haptic surgery platform called VRHSP. Trainees can train outlining and incision steps of skin tumor surgery in this platform. So our contribution is developing the VR HSP. The, the platform provides virtual world view through VR devices and haptic feedback by haptic device. We create the image-based haptic rendering algorithm and evaluate the effectiveness of the VRHSP's haptic feedback on human participants from two different groups, which are medical and non-medical participants. Then we designed the matrices to objectively measure accuracy and efficiency of skin tumor surgery. In the term of immersive, the system provides realistic virtual environment through VR device. A trainee can experience the realistic surgical space with skin tumor image and surgical tools. The haptic device enhances the immersive experience. The surgery process becomes more realistic by providing realistic haptic feedback while proceeding surgery in the platform. The picture shows the participant experiencing the surgical environment while training the surgery steps. The system is closely connected to the learning surgical skills. Our platform led trainees to train the surgical skills and evaluate immediately to make better progresses. The metrics show the evaluation guidelines for the platform. For the outlining, the time spent for the outlining and the Euclidean distance error between the answer outline and the outline from the trainee are the matrices. And in incision task, time spent and depth error from idle depths and XZ angle of the scalpel and accuracy and efficiency of the cut surface are the metrics. The pictures on the right show the outlining and incision training with VRHSP. Our first method is developing the VRHSP. The diagram on the left shows the overall system architecture. Our system gets input as skin image used for generating haptic rendering and visualized in the simulation, with two different tasks which are outlining and incision. The user can feel the haptic feedback and visual feedback through our system. For this study, the total 10 skin images were captured with a DSLR camera by photographing Fox skin tumors. Our system basically uses surface haptic rendering with virtual proxy methods by Rospini. In this platform, uh, there are 5 haptic parameters for the surface haptic rendering, which are stiffness, damping, dynamic friction, static friction, and pop-through. The pop-through parameter defines the amount of force required to break through a haptic rendered surface. We created multi-layer surface haptic rendering to create inner skin haptic feedback. Beyond the skin, there are multiple layers that has different haptic feedback. To generate realistic cutting feeling of these layers, each layer consists of multiple plane meshes. The equation generates equal interval pop-through parameter to each mesh in a layer to provide realistic haptic feedback. We experimented with 5 medical participants and 5 non-medical participants with our platform with 2 different conditions, with haptic and without haptic. NMP is non-medical participants and MP stands for medical participants in the slides. These data, uh, are the quantitative and qualitative data from the experiment. In summary, both groups showed less depth error, X and Z angle error, and spent less time with the haptic in incision task. And the X and Z angle error showed significantly different result between non-medical and medical group. The qualitative results from NASA TLX and questionnaires showed the system with haptic feedback was overwhelmingly preferred. From this result, we implicate that in terms of usability of the platform, we found that the haptic feedback provides better performance and the platform has the ability to discriminate the non-medical participants from the medical participants. In conclusion, we developed the VRHSP with the new haptic rendering algorithm. Also, we created metrics for the system and evaluate the platform. The VRHSP with haptic feedback showed better performance than and the better preference than without haptic. In the future work, we aim to expand the system to a bimodal platform. MR and MR, which is mixed reality, and other haptic devices will be included in the system. We have small number of participants in this initial study, so we will make more samples to avoid bias and get more accurate results in the future. And we only cover 2 steps of skin tumor surgery from total 9 steps. So in the future, we are aiming to cover all steps. Thank you very much.